Section 2.9 starts to sound like it's the same thing as what we did before. It has the word complex in there. We talked about complex fractions last time. We're going to talk about complex numbers this time. Complex numbers come from the imaginary unit, which is the square root of -1. So the imaginary unit I is defined as I squared is equal to 1, or as I is equal to the square root of -1. So in this section, we're going to deal more with imaginary units in college algebra, but in this section, what we're going to be doing specifically is just talking about how to work with them. And interestingly enough, for the most part, they work very much like working with a variable x or y. There's one component that's slightly different, and it has to do with the fact that when we do end up with I being squared, it does equal -1. Okay? So, for example, oh my goodness, just a second. We have a -5 underneath the radical. Okay, this is the same thing as having a -1 times 5. So that's probably the only time I'm going to actually write this. Okay, but that's what it really means. So when we have the square root of the -1, from our properties of radicals, we learned that the square root of -1 could be multiplied separately like this. And on the previous screen, we said that the square root of -1 is I. So this is I square root of 5. Now, you can shortcut all of this and go straight to the end, and that's what we're going to do kind of on the next one. The negative means, that is the negative underneath the radical means, I have an I if I pull it out. So normally I'm looking for pairs of things or three groups of things or groups of 3 or whatever. Anytime I have a negative underneath the radical, it comes out of the radical as an I. That's what it does. So right here, this is the same as the I here, and then square root of 8. Now, on the last one, square root of 5, we were done. And we were done because 5 doesn't factor into anything in pairs. 8 does, so I'm not done on this one. I would need to factor my 8. It's 4 and 2. And then the 4 is 2 and 2. So there are 2 2's that are underneath the radical. So just like we've done in previous sections, it was your favorite section 1.10, right? The 2 will come out with the I, and I'm left with the square root of 2 underneath, or the 2 underneath the square root. Okay, so all the radical stuff we did before is the same. It's not going to be as messy as the things we saw back in that section, so maybe that will help you to feel okay about that, but there's going to be negatives, and negatives are going to come out as I's. So on this one, what you have to recognize is that there's a piece that's a negative that comes out, or an I that comes out, and it's square root of 3. And over here, an I comes out, and it's square root of 12. Okay, that's what it is. But now you'll notice that I have an I and an I. That's I squared. And then I can put all the values underneath the radical together, the 3 and the 12. I need to factor my 12 still, so we'll do that next. But the I squared's in front, and I have 3 and 12. 12 factors is what? 4 and 3, and 4 is 2 and 2. So this one's very interesting, not like the ones before, because I have 2 2's, and I have 2 3's. So what does that mean? You would, you're right. So I'm going to bring, there's already an I squared out here. I'm going to bring the 2 out. I'm going to bring the 3 out. There's nothing left underneath the radical. I've pulled everything out. So, I'm sorry, that was that I squared. So now I'm left with 6I squared. Now, in most of the things that I've done, I've told you that I is going to act like a variable, and you're about to see that happen in the next problems. But the caveat to this is right here. What's I squared? It is -1. So this is actually 6 times -1, or -6.
So -6 would be our, that would be our final answer?
It would, yes.
And even if it's squared, it still is -1?
I squared is -1. That is by definition, yeah. Okay, now number 4, you'll see that we have that square root over the square root. We still have the negatives underneath there, so we're still going to pull them out. I have an I square root 20, and I have I square root 2, right? But what happens when I have a factor of something on top and a factor of something on bottom, like this I over I? They cancel, right? They do. So these are going to cancel out just like that they would have if it were a variable or a number. It is a number, but a traditional, like a whole number that we've been working with. We have the square root of 20 and square root of 2. I can write them underneath the same square root. What is the square root of 20 divided by 2? Square root of 10. And square root of 10 does not simplify. Okay, any questions so far? Kenny? Oh, I did, yes. I have 10 by dividing 20 by 2. Kenny?
On the last one, where did the I squared go?
It didn't go anywhere. It's equal to the value of 1. So I simply replaced I squared with the negative 1.
So the square doesn't really have anything to do with it?
It does. It's what makes it negative 1. I squared is negative 1. Yeah, so anytime we end up with I squared, we're going to replace that with negative 1 because they're equivalent. Okay. Oops. I'm on 5. There we go. Here's the cool thing on 5 and 6. It's just like working with variables. Like terms are like terms. So here is the 2 and here is the 6. They're like terms, so that makes 8. And I've got a negative 3i and I've got a positive 2i. Those are like terms, so that makes negative I. Okay, adding and subtracting with imaginary units with these easy stuff. So again, I have the whole numbers, and it doesn't even have to be the whole numbers written first, they just are, or the integers. I have negative 4, and then this one right here, I do have to be a little bit careful. This negative needs to be distributed through. So this is negative 6 and positive 6i. So let me just rewrite that first. Here we go. So I have negative 4 and negative 6 makes negative 10. And then we have 2i and 6i making positive 8i. Okay, so here's the deal. I told you I didn't think it was a 10-minute lesson. It's short. It's probably only 5 more minutes. I have 2 options, and I'll let you pick. One option is that I can record the next 5 minutes, and you can finish it over the weekend. The second option is that it's going to end up with you having 2 sets of homework due on Tuesday. Both of them will be due, and you'll have homework from Monday and today, all at the same time due on Tuesday.
I don't want that. I don't want the last one.
I think you should record that.
Would you like me to record the last 5 minutes?
I don't like having
Okay.
all of it.
So what I will probably actually do is, this is already a super short video, it's only 8 minutes, so I'm just going to pause it for now. I'm going to let you guys leave. I'll finish recording it in the classroom, and you can just pick up at about 8 minutes into this video once it's posted, okay? Sound okay? Cool. All right, so we're going to pick up with the last 4 questions that I didn't have time for. Question number 7 and 8 both show what happens when we have multiplication. So we're going to distribute through the multiplication just like we would have if we had variables, okay? So I have 5i times 2, so that's 10i, plus, and then I have 5i times 3i, so that's 15i squared. Now again, the caveat that we found out, on an earlier problem, which one was it? Let's see. On problem number 3 is that when I get an I squared, it equals negative 1. So this is 10i plus 15 times negative 1, or 10i minus 15. Okay? The next one, much like, again, the algebra that you've seen with variables, we're going to distribute it out. So first, outer, and then inner and last. The first term's 2 times 3 would be 6. Outer, 2 times negative I is negative 2i. Inner, 2i times 3 is 6i. And then the last terms is 2i times negative I, or negative 2i squared. These two, of course, are like terms. So I've got 6 plus 4i. And then the last one has an I squared in it. So I squared equals negative 1. So the I squared is replaced by the negative 1. I have 6 plus 4i. And then negative 2 times negative 1 is positive 2. And then we see that the 6 and the 2 add together, so I have 8 plus 4i. Or if you wanted to, you could write it as 4i plus 8. So that's how multiplication looks. Very, very similar to multiplication with variables. I just have that extra component on the end that I squared is equal to -1. All right, our last two questions are about division. And we saw this particular concept that I'm going to show you happen when we did this with rational numbers. Again, that was back in section 110 that you didn't like so much. But we talked about the conjugate, and the conjugate was the same thing in the middle, or the same thing that we had, in this case on the denominator, but with the opposite sign in the middle. So instead of 3 plus I, we will multiply by 3 minus I. Okay, so on the top, we're going to distribute this through. So I have 2i times 3 is 6i. And 2i times -i is -2i squared. Okay? On the bottom, I will distribute it out. But notice the inner is positive 3i, the outer is -3i, and they will add to 0. So I only end up with the first and the last. The first is 3 times 3, or 9, and the last is I and -i, which is -i squared. So we have two places here where we have I squareds. They will be replaced with -1s. So I have 6i minus 2 times -1, and 9 minus -1. So minus and negative in both cases will end up being positives, right? So on the top I have 6i plus 2, and on the bottom I have 9 plus 1, or 10. Notice on this one though, they're all even. I can divide each of my terms by 2. So my last step will be to simplify and do just that. So 6i divided by 2 would be 3i. 2 divided by 2 would be plus 1. And then 10 divided by 2 would be 5. And our last one, same as the one before, has a imaginary unit in the denominator. So anytime we have that happen, we're going to multiply by the conjugate. So that's 4 minus 2i, right? Same values, just opposite sign. On the top, I'm going to actually have to distribute that out. So I have the first terms. So 2 times 4 is 8. I have the outer terms. 2 times -2i is -4i. I have the inner terms, -i times 4, so another -4i. That, of course, doesn't always happen. And then our last terms, which is -i and -2i, which would be positive 2i squared. Now the denominator, again, the whole point was that I multiplied by the conjugate because the inner 4 times 2i is 8i, and the outer 4 times -2i, -8i. They cancel. So if you want to write the FOIL down all the way, that's fine, but the inner and the outer terms will cancel. So we only really have the first terms, 4 times 4 is 16. And the last terms, 2i times -2i, which would be -4i squared. All right, so the two on top that match in terms of the terms are -4i and -4i. So this is 8 minus 8i. And then I have an I squared on top and an I squared on bottom that will be replaced with -1. So I have plus 2 times -1. On the bottom, I have 16 minus 4 times -1. So on the bottom, I have minus a negative, which is positive. On the top, I have 8 minus 8i minus 2. On the bottom, I have 16 plus 4, which is 20. Now, the 8 and the 2 can combine. So I have 10 minus 8i over 20. And much like on the last problem, I end up with something that I can reduce. That, again, doesn't always happen. It has happened on both of these, but won't always. They all divide by 2. So I have 5 minus 4i over 10. Okay, so that's the end of this lesson. You should be able to do the homeworks on these now. We'll, of course, do homework questions at the beginning of class. And I expect there might be a few over that last part because that's the messiest part, this conjugate idea.